Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. I am happy to have Automotive Seminars as a sponsor for the show. Now, if you're not familiar, Automotive Seminars is a diagnostic technician training company. They've got a website that there'll be a link to in the show notes. And what they offer is top-notch training to technicians like us in the field. I've been taking their training courses for years and have got a ton of benefit out of it. They've got top-notch instructors, John Thornton, Scott Shotton, Scott Manna, and every other month they've got a 2-night course that you can sign up for. Join in, ask questions, and afterwards, you've paid for the course, you can access a recorded version whenever you want. You can rewatch the class 2 years later in case you wanted some details on it. And that is a fantastic feature. So make sure to check out the website to see what courses they have available and what's coming up in the future. This podcast is brought to you by Jarhead Diagnostics. Jarhead Diagnostics manufactures in-house diagnostic equipment and storage solutions, as well as distributes for companies like Pico, ATS, and TopDon. One of my favorite tools that I've bought from Brandon and Jarhead Diag is the case for the U-Scope. If you don't have a U-Scope, you probably should, but if you have one, you got to get one of these 3D printed cases, has a magnet on it, has a full-size BNC lead that you can connect to, and it gets rid of the weak point of that scope, which is the mini BNC connection, which is pretty fragile. This case makes this thing nice and secure and makes it an even better tool than it was. So check out jarheaddiag.com. The link is in the show notes. Hey, for listeners of the show, if you want a discount on Jarhead Diagnostic products, use discount code DIAGPODCAST. That's DIAGPODCAST, DIAGPODCAST, for 10% off purchases from jarheaddiag.com. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping. I'll be your host once again for this week's episode. Thank you for joining me. I've got a fun vehicle here for everyone today. This is one that actually isn't even 100% completed. There might be even more to this vehicle, but I've worked through quite a bit, and I think we at least got to the reason why we had some problems with this car, because it was very, very strange. And so you'll understand as we get into it. But let's do that. It's a 2015 Chevrolet Traverse. Plenty of those things out on the road. Work on lots of them. Various issues. The Acadia and the Enclave are the same thing, and they're all over the place, at least up here in Minnesota. It seems like every other person drives one of them. And we're fairly familiar with some of the issues we see with this thing. But a shop called me and said, hey, we've got a no crank situation, and the battery seems to be dying, but our main concern is the no crank situation, right? The vehicle doesn't start. Okay, cool. They want us to come diag it and see what's going on. So this is actually a shop that's kind of on the northern end of the territory of what I cover for my company, and my employee actually lives up that way. So when we have stuff at this shop, I try to have him hit up whatever it is, just because it makes more sense geographically speaking. And so the first, I think 2 or 3 trips were all done by my employee, Steve. And then eventually I got involved too, because this one was a strange car. But anyways, send Steve up there for the no crank, and he goes through the basic checks and finds very quickly that the ECM, engine control module, is a no communication, right? It doesn't talk to the scan tool. There's other modules reporting, can't talk to the ECM. And we go into our basic checks for module communication on a GM, which we do a lot of, and we're pretty well versed in, both of us, right? And He ends up at the engine control module, which is pretty easy to access on this thing. And we're checking for powers, grounds, and communications. All very simple, right? Very straightforward. That's all you need for a module to communicate. And if you pull up the OE diagram for GM, they label in one diagram everything you need to talk to a module, which is really nice. I wish all manufacturers did that. Some do outside of GM, but I think GM does a really good job of I use Identifix a lot, and I'll go into the OE diagrams, I'll type in ECM, it'll break it down into sections. So there'll be like fuel controls, ignition controls, and then one of them, usually at the top of the list, says, power, ground, communication, maybe like ignition wake up, but it's all in one diagram and has everything you need for a module to talk, which is super handy, right? I mean, especially if you're just getting into this, if you're not really well versed in, what do I need for a module to talk? Well, guess what? It's all here, right? This is constant B+. This is ignition wake up in a couple different places. This is CAN communication, and this is ground, right? And one of those ignition wake ups, because there's more than one, is actually a serial data wake up, but it's all there. So if you go through and you check everything on this diagram and it's all there, well, guess what? It's the module, most likely. Of course, there's always an exception to the rule, but it's a really good reference. If you're not sure, what do I need for a module to communicate? Check out that portion, that section of the diagram, and check all that stuff, verify through testing that it's all there. If it is, you know where you're at. So that's exactly what my employee did, right? So we got a couple grounds, check those. We're using a headlight bulb. Let's pull 4 amps through that circuit, make sure it can pull some current. And it has good ground. Constant B+ has same thing. We're referencing ground. We're putting ground on the other side of that headlight bulb, check power. Ignition wake up, it's there. Now, again, I mentioned there's 2 separate ignition wake ups for this module. One that's through a fuse, and then another one that is from the BCM, and it is for the serial data wake up, right? Meaning that if this is not there, the module might actually turn on and do some things, but it won't talk on the CAN network if that's not there. And that's missed on a lot of modules. I've replaced modules by other shops where I'm called in that are no comms for that very reason, because they didn't realize that there is a serial data wake up and it is supposed to have power there when the key's on from the BCM in order for that particular module to talk. Anyways, that's one of the checks. Make that's there. We check the actual CAN lines. And before we even got to this point, on GM specifically, because of the network architecture, we're going to do a check at the DLC between 6 and 14 with no power to the vehicle, however that takes, whether it's key off or battery disconnected. We're going to check between 6 and 14 and make sure there's 60 ohms. And this all goes into understanding the network construction, but GMs, most of the time, I can say most CAN bus style GMs are going to put the ECM, the engine control module, at the end of their daisy chained network. If you think it is one big loop, and they'll have a terminating resistor within the ECM. Of course, you can check the network portion of the diagram to verify that, but that's true most of the time, right? It's at the end of the network. And the reason I bring that up is because if we get 60 ohms, it means we've got 2 120 ohm resistors in parallel, both connected to the network, and 60 ohms measured at the DLC means to me on a GM a ton of information. It means that everything is plugged in on that network and connected. There are no opens in that CAN bus anywhere. That's huge information, right? It tells you a lot right from the DLC with a really easy low-cost test. Okay, and we made that check. So we knew that physically the network was connected, but we made the check anyways that, okay, it does have actual CAN bus activity to those 2 pins on the network. And that's an easy check to make too when you're right there at the connector. So we got constant power, we got ignition wake up, we got ground, we got communication, we got serial data wake up. It's all there. Now, the one thing my employee did notice when he was going through his checks was that there was no power on pin 73 of one of the connectors. And actually, I didn't write down the connector name. I think pin 73 is ground on one of them, but it is a power feed on another one of those connectors. And where this comes from is the engine controls ignition relay. And I think in some previous GMs or some previous vehicles, this was like a PCM power relay. Maybe I'm thinking a different manufacturer when I say PCM power relay. But anyways, what this is, if you look at the diagram, it's in this diagram, it's a relay that is controlled by the ECM that sends power not only to this point, it sends it to others, but it sends power back to the ECM. And we see this in a lot of applications. And this is actually a point of confusion for a lot of technicians, including myself at some point, because the ECM essentially powers itself up. And when you just look at a diagram, it's confusing. Like, okay, it's like a chicken and an egg thing, right? Like, where does it start? If the PCM supplies power to itself, how does it do that, right? Well, I can say in almost every scenario that I've dealt with, and I do say almost, I'll explain why, you don't need that circuit to be powered up to talk to the module, right? Once the key's on and the ECM receives its wake-up signal, it will ground the control side of this relay, and then that relay will send power back into the ECM on this pin 73. And as far as I've been able to tell over the years, this power, this particular circuit and the current that's going through that wire is used to power different components through the ECM, right? And maybe some things that are doing some work. But that power on that circuit is not necessary for the ECM to talk, okay? So if you don't have power there, it's generally speaking not a big issue if your concern is no comm with the ECM. Now, there are exclusions to that rule, right? And I'm thinking early 2000s or mid 2000s Toyotas, like the Corolla, like the Matrix, Vibe. That's what I'm thinking. And I have seen those where the PCM power relay, where it basically excites itself. If that does not have power, you can't talk to the ECM. I've seen that a couple times. So it's not to say that 100% of the time, if you see that setup and you're dealing with a no-comm situation, that it's not an issue. It can be, but for most of the vehicles that I deal with, and I guess the ones that are coming to mind here are GM and Chrysler, and the ASD relay would take the place of this relay in a Chrysler application. You could pull that relay out and you could still talk to the ECM if everything else is there. Okay. And so anyways, my employee goes through the checks and he notices there is not power here. And he's trying to be as thorough as possible. And he's aware of the same things, that I am, but he's being as thorough as possible. And he's like, well, okay, there's no power here. I'm going to jump this relay and just see what happens here. So he jumps the relay, this engine controls ignition relay. And in the diagram, it shows it powers up a whole bank of fuses, right? There's 5 or 6 of them that receive power from this relay when it's activated by the ECM. And one of those fuses feeds directly into the ECM. Well, he has no power on any of the fuses that this relay powers. When it's jumped 30 to 87, straight jump with a jumper wire, there's no power on any of these fuses, and there's also no power to the ECM, which if you don't have it at the fuse, you're not going to have it at the ECM. And so he thought that was odd, that it didn't, something else was wrong there. So he called me, and he's like, hey, this is what I've got. I can't talk to ECM. I think I have everything I need at this ECM, but there's an issue on this fuse box side of things. Okay. And I go through it with him and I'm like, double check this, verify this, make sure you're on the right relay, make sure you're checking the right fuses, double check how you have your test set up, right? Is your, if you're using a test light, make sure that it's connected, it's actually making good connection wherever you're referencing it on ground, all this stuff. And not to say that he wouldn't do this stuff, but I'm not there at the car. And that's the things I would do to myself. I would move my ground on my test light to make sure, okay, I think sometimes that happens to me. I'll find something like no power on a wire, and I'm like, well, that's too easy. And I'll go and I'll move the ground on my test legs. I'm like, there's got to be something else going on here. And I'm like, oh no, there really is no power on this wire. Oh, it's really a fuse, right? And so I'm going to ask them the same stuff, like double check your test methods, double check to make sure we're on the right fuses. And I looked up the diagram where I was at, and I was like, okay, yeah, everything checks out to what you're saying. I was like, well, I don't think it needs power from this relay for the module to talk. I've dealt with lots of GMs. It's not the case. You don't need that. And so I was like, just jump power to that circuit at the ECM and just see if you can talk to it, right? We know we have everything else. Let's just jump power where that relay would supply power to. And I don't think it's going to change anything, but let's do that. And so we did that. Still can't talk to it. But there's still an issue in the fuse box. And we go back and forth with it. And we're like, well, yeah, it definitely needs DCM. For sure, but it sure seems like it needs a fuse box, right? The connection between the output of this relay and the fuse bank, or the bank of fuses that need to be powered up from this relay, is internal to this underhood fuse box that's over on the right-hand side of the underhood. And there's clearly an open in there. You know, you ohm checked it. And again, we double checked to make sure we were right on the right terminals and all this stuff. And there's an open in this fuse box. I was like, well, that's really weird for both of these things to be bad. But he's confident in what he's seeing, and I'm confident in what he's telling me. So I'm like, okay, we'll tell the shop exactly what you found, and this is what it needs. Strange, very strange. I don't know why, but hey, it is what it is. And that's the beauty in my eyes of understanding test methods, performing the test methods, and getting the results, because it doesn't lie. As long as you're doing it correctly, it doesn't lie. And you know exactly what has failed, and you can prove it with test methods. And there we are. Okay. So, and the shop's fine with it. They're like, okay, we'll get a fuse box for it, and we'll get an ECM for it. And of course, the question's running through my mind, like, why both? But okay, let's get them in there and see what happens. You know, I'm not at the car, so let's get those in there. They'll call us back up when we have to program it, and we'll kind of reassess there as to if there's anything else going on. So they do. They get an ECM. They get a fuse box in it. This is just a fuse box. You don't have to program it, but you do have to program the ECM. The employee goes up there, can talk to it, communicates. So that's a good sign that we made the right call. Programs the ECM, goes through the steps in addition to programming, one of those being a crankshaft relearn. So he goes to start this thing. And it starts and it kind of stumbles, and then it doesn't want to start, and he's looking into it, and it doesn't have any fuel pressure. Okay, you can look on the scan tool and see the fuel pressure data PIDs. It doesn't have any fuel pressure. It cranks, doesn't have any fuel pressure. It looks on the gauge. It does have gas. And he calls me up. He's like, well, I can talk to the ECM, and I've got communication with it, obviously. So we've made forward progress. And so I asked him about that fuse panel or the fuse box. I was like, do we have power out of that relay now? And we do. You know, we're getting it to those fuses. And so everything has power that it needs to. But for some reason, we don't have any fuel pressure. And I thought that was really weird. He also mentioned that the left side turn signals were just on, and the battery was dead when he got to this thing. But when he jumped it, he's like, yeah, there's a couple of lights on the side of this thing. And I asked him if they were beforehand. He's like, I think they were, but I really wasn't paying attention to that on the first trip there. I was like, okay, whatever. But this thing's outside of this shop. It's not inside. And the fuel pump has no access panel. The fuel pump control module's underneath the vehicle. And we had just allotted for programming there, which we did. And I told them, okay, let's tell them, number one, to get a charged battery in it, whether it's charging that one or getting a new one in there, and get it inside so we can get it on a hoist, call us back. We'll be back up there next day. So we do that, move on with our day. And so they get it all ready for us, call us back up, and we were pretty busy that day, but I got my employee up there at the end of the day as he was heading home, right? Because, again, it's kind of up by his place. So he hit it up on his way home, and on the hoist, ends up finding, okay, we have no fuel pressure, and the reason we have no fuel pressure is because we have no communication with the fuel pump control module, which is underneath the vehicle. So he does his checks at the fuel pump control module. finds there's power, there's ground, there's ignition, wake up. It's all there. It's all present, just like at the ECM, everything we're looking for. And there are 2 CAN lines that go to the fuel pump control module. And it's important to note that the 2 CAN lines go directly to the ECM and nothing else. This is a dedicated, independent CAN bus network that is between the engine control module and the fuel pump control module. And GM's been doing this on a lot of vehicles that I've seen recently in the 2015 and up range, where it's just an independent communications network between these two. Actually, the Silverado, I think I had an episode on where I talked about this network. But anyways, nothing else is on this network, but it's still a CAN network. Each module has a 120 ohm terminating resistor in it. So you can measure that network and it should be 60 ohms. My employee does some checks. He says there's something wrong with the CAN bus between these 2 modules. And he did his checks. He's got a U-scope and he was trying to figure out exactly what was going on. And he wasn't able to 100% place what was happening. He just said something is wrong with the communication between these 2. And he did note that there was a communication code in the ECM for no communication with the fuel pump control module. He said he wasn't sure if that was there when he was there the day before, but it's 100% there now. Can't communicate with it, and something doesn't look right. We tried to walk him through the steps, but again, it was the end of the day. The shop was closing up. And so at this point, I'm like, hey, I'll come up there in the morning, because it's tough doing stuff on the phone, especially when I'm busy, especially when it's the end of the day. And sometimes it's just easier to say, okay, I'll personally run up there and I'll go through this and we'll figure out what's going on here. Because I'm also thinking at this point, like, what else could be going on with this car, right? We've already found 2 failed components, and now we're leaning into something else that's failed. Like, something just seems very odd and strange. And we haven't even addressed these lights that are constantly stuck on. Both the front and rear left turn signal bulbs are on all the time, including key off, which is why their battery was dead. And this didn't really become clear until we talked with a shop, and they're like, yeah, these lights have just been on. We had to disconnect the battery. Okay, so just something's up with this car. So I did talk to the owner of the shop at this point, and I was like, do you know anything? Is this a auction car, or did you guys do any work on this? Was it in a collision? And they said no, the customer was just driving it, and then they were having some issues, and they got it to us, and they wanted us to fix their no crank issue. Like, well, I mean, I guess we did, but there's clearly a lot of other things going on. So I get up there and I check, and Steve was right. There is a communication issue between the ECM and the fuel pump control module. Now, if you unplug the fuel pump control module and you check that CAN network, it's got activity. And it doesn't look perfect because you've halved the terminating resistance, but it's there. And you can see the ECMs reaching out to say, hey, fuel pump control module, where you at? It's just a repeating message that goes out onto that CAN bus because nobody else is there. It's just the 2 of them. You plug in the fuel pump control module. I'm back probed in looking at this CAN bus, and it drops to 0. So it goes from activity, 2.5 to 3.5, 2.5 to 1.5. It goes from that to nothing. It drops down all the way down to 0 on my scope. And I think this is what my employee was seeing too. And one thing that I just want to get out there on the podcast for everybody doing testing, because it does seem to trip up technicians quite a bit, is when we're using testing equipment like a scope or a meter, and you're referencing ground, which we do for most of our tests, not all of them, but a lot of our tests, our black lead for our meter or our scope is connected to a ground. And whatever we're measuring either goes to or just shows us 0. Like, it's at the bottom of the scale. It's a 0 on a meter. Whatever it is, it shows us 0. I want you to always ask yourself, is this 0 like nothing? Or is this 0 ground? Okay. And if you're referencing ground with your meter or with your scope, you really probably can't answer that question accurately. Maybe you can take a guess, but I don't think you can accurately say, yeah, that's definitely 0 meaning nothing, or it's Zero, it's a ground if you're referencing ground, right? And think about this, right? If you took a meter and you put one lead on the ground terminal of the battery, your black lead's right there, and you took the other lead and you stabbed it into the engine block, like you were making contact, well, you'd show zero on that meter. Okay, maybe if you got some current flowing, maybe you show a little bit of voltage drop, but most of the time you're just going to show zero. Or any ground that you put that red lead on the car, you're going to show pretty close to zero. And then if you hold the meter up in the air, right? So I still have my black lead on my negative terminal and I have my red lead up in the air, not touching anything, I'm still going to see zero, right? And same thing with our scope. And I had a lot of trouble with conveying this concept to students too. To think about when it's zero on my meter, is it really zero or is it ground? And the second question to that is, how do I verify? If that thought pops up into my head, is it zero? Is it nothing? Or is it ground? Because that's different. Those are two different things, right? How do I check for that? And I'll tell you one of the ways I do. Now, you can reference your scope or your meter to power and do it that way, but be careful because your meter, especially your meter, and especially if you're doing this open circuit, can show a ground, right? If you reference it to power and you're using your black lead to touch things, it'll show ground when there could potentially be a lot of resistance in that circuit. That there's a lot of variables there that I don't want to get into, but here's my method. Here's what I do if I suspect that there is a ground on this circuit. Okay. And going back to this circuit, it went from activity on this CAN bus to zero, flat line on the scope. I'm going to use a powered up test light to see, is this a ground, right? Is there a current carrying path to ground, which I'm suspicious of in this case. So power up my test light, connect it to B plus on the clip side, and the pokey side, I'm going to go onto the circuit that is in question. All right. And if it lights up the test light, I know that's a current carrying path to ground. And I don't need to go tell everybody that shouldn't be on a CAN bus. You shouldn't have a current carrying path to ground on a CAN bus. You definitely shouldn't have it on both sides, but I did in this case. So I touched both sides of the CAN network. It lights up my test light, which is powered up brightly, path to ground. Okay. And this is with the fuel pump module plugged in. So I unplug the fuel pump control module and my test light no longer lights up, and I can scope those CAN leads and they have activity from the ECM. So there's a direct short to ground inside of my fuel pump control module. And we verified it with an ohm check. Not that that was necessary, but I'm just like, I want to prove myself wrong in this case. Cause I'm like, my thought process here is like, something's wrong. Like, we had an ECM confirmed that there was a no-com. Okay. We had a fuse box that we confirmed was open. And I was thinking in my head, well, wait, maybe this fuel pump control module was causing the ECM to not com, but I can plug that fuel pump control module in and I can talk to my ECM. So I know that wasn't the case. This fuel pump control module is shorted to ground internally. So we have a third component that's failed here, and we're not even done because they wanted me to look at the lights. So I'm starting to think at this point, like, again, something happened to this vehicle. I don't know what, but something definitely occurred to this thing that's causing multiple module failures. And of course, the immediate thought in my head is maybe they jumped it backwards. And even the tech I was in the bay next to was like, I think they jumped this thing backwards or something. I'm like, yeah, it's very possible. So lower it down, and now I'm going to go after the lights, right? I've confirmed fuel pump control module shorted internally to ground on the CAN lines. Now I'm going to go after the BCM, which controls the turn signals, right? If you look at the diagram on this, the BCM is the driver. It controls the output circuits to both the front and the rear turn signals, and they're independent circuits from one another, which, based on all the things I've seen on this vehicle so far and the circuit diagram, that the left, actually there's a mirror and a left front that share an output driver from the BCM, but a completely separate circuit and what it shows as driver. Maybe the driver's the same internally in the BCM, but a completely separate circuit powers up the rear for the left turn signal, both of those are lit up, right? And of course they have power. I can check that. But here's what I did. I found the connector. There's 6 connectors on this BCM under the dash. I found the connector with both output circuits for the turn signals for the left side. I unplugged it. Those lights go off. So I know that there is not power shorted to the circuit. And then I took my test light, grounded, and I touched the terminals with the unplugged connector to see, do they have power on this BCM? And I'm hoping that the connector that I unplugged didn't supply any important power sources to the BCM, but I had power on both of those pins, like right out of the BCM. Okay. And so the BCM was definitely supplying power on those circuits because the lights went off when I unplugged it. The power was still there on the pins with it unplugged. Okay. So the last thing I really need to look at here, and probably I would have checked this first in a normal scenario, but my mind's already thinking this BCM is internally shorted. Okay. But I'm going to communicate with it, pull up scan data, look at the input from turn signal switch. It says inactive. It says command for the turn signals off. When I flip the turn signal to the left, it says active for the switch. And then the command it goes to on, but then it starts to blink fast or give you the indicator on the dash that it's blinking fast, right? Like a bulb's out or something when all of the bulbs are, they're lit up, but they're constantly lit up. Anyways, the driver for the left turn signals is shorted internally on this BCM. And I'm just like, okay, what else are we going to find on this thing? So I get talking to the owner with all of these things that we've found. I'm like, this is not a normal vehicle. Like, things don't happen like this just all of a sudden. Like, what happened to this thing? Is it a flood car? Is it an auction car? Did they jump it backwards? Did it get struck by lightning? And he kind of laughed when I said that, but I'm like, I'm serious. There's been a lot of storms around here lately. I'm like, you need to question the customer and get some more information because something happened to this car. And here's what I know is bad right now. I know you need a fuel pump control module. I know you need a BCM. We have all the tests to prove the components we already replaced, because he was getting a little, I don't want to say suspicious, but questionable about our diagnostics at this point, because we've recommended, several different things in a row and the car's still not fixed. But I'm like, we have all of the proof to show you why all of these things are bad. And we're making progress. It didn't crank before. Now it does. It didn't calm before. Now it does. But this is not a normal thing that we run into with this many failed components. And according to him, the customer was just driving it. But I'm like, you got to question these people. Ask them, did something happen? What was going on? So he did that. He called them up and, explained the situation to them because the customer is getting antsy. This is about a week of time, this whole story, us back and forth. And they messed with it for a little while themselves too. Well, it turns out they were driving in a thunderstorm, and we've had some pretty wild ones up here lately, and they got caught in this thunderstorm. And he talked to the lady who was driving the car. She said it was so loud she thought she was in the thunderstorm. Well, yeah, I think she was. And now the interesting thing was that they said they drove it home. And I don't know if that 100% jives with what we found, but what we're guessing on this vehicle is that it was struck by lightning, because they got it home and then it didn't start after that point. And according to them, they did not jump start it, because that was my leading suspicion, is maybe this thing was jump started backwards. But according to the customer, and we can't verify that 100%, they didn't try jumping it. They just parked it after they got it home, and then it would not start, and all of these problems happened. But she said she had to pull over on the side of the road because she thought she was in the thunderstorm. So my assumption, we did look for witness marks on top of the vehicle, didn't see any. So that part of it was like a little, hard to confirm the story. Personally, I haven't dealt with any lightning strike vehicles, so I don't know if you always see a witness mark, but we are definitely guessing that this thing got struck by lightning, and that's what caused multiple failures in the electrical system of the vehicle. So we're going up tomorrow to finish the programming on the BCM, and we'll see. And I told him, I was like, we might have other issues. I wouldn't be surprised if we have other issues in other parts of this car based on what we found so far. And he understood, and the customer understood. So we're going to take this module by module and just kind of see how it goes. So if there's anything more interesting on this vehicle, I will be sure to fill you in. But I thought that was all pretty interesting, so I wanted to share it on the podcast. So, hey, if you've dealt with a lightning strike vehicle before, let me know about it. How did that go for you? How many modules did you have to replace? How did you come to the conclusion that it was struck by lightning? Was it obvious? Was it not so obvious? Did you see a big burn mark on the top of the vehicle? I think it's pretty crazy stuff. So anyways, thank you for listening. I really appreciate it. Honestly, I really do. Thank you for listening to the podcast. But with that out of the way, let's get out there, start fixing the world one car at a time. Hey, it's me again. This is Sean 24 hours after recording this episode. We went up there this morning, programmed the BCM, got that all taken care of. Turn signals work. We didn't notice any other electrical problems right now with the vehicle that were obvious, but started and ran the vehicle, and the thing needs timing chains. So I don't know why I find that humorous, but it is a GM 3.6 and had high mileage. So I guess I'm not too terribly surprised, but I don't know. It was just kind of, I had a chuckle this morning after all that effort and all those parts replaced. And yeah, it's going to need timing chains too. So I'm sure that had nothing to do with the lightning strike or whatever happened to this vehicle, but thought I'd fill you in. So thanks again for listening.